This meeting is being recorded.
Okay, so today we will discuss about dynamic routing protocol. We'll start with RIP. But before we move on to the today's class, have you guys understood the concept of routing? How does a route table look like, and how does shortest prefix will be longest prefix match will be preferred, and the administrative distance will be used? Have you guys understood all of those concepts from last week?
Yeah.
Good. Okay. Do you guys have any questions on that? No questions? Okay, that's fine then. We'll talk about RIP. RIP is basically a distance vector protocol. So let's talk about what is distance vector, right? Let's talk about a distance vector. Let me share my screen. So this is router 1. This is 2, 3, 4, 5, 6, 7, and this 7 and the destination. And 2, 3, 4, 5, 6, 7. Okay, so for router 1 to reach to the destination, it has to either go with the pattern like this. That's one way. And then there is another pattern to go via this way. The router will choose whichever has the least number of hops. For this path, there is like 1, 2, 3, 4, 5, 6, and 7 hops to go that way. And for this one, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 hops. So the distance vector protocol is nothing but it will calculate the total distance, the total number of hops to reach the destination. Whichever has the least number of hops, that path is preferred. That is how a distance vector protocol will work. So RIP is a distance vector protocol. So RIP can carry the routing information based on how many number of hops to go to the destination. So there are two versions of the RIP, RIP 1 and RIP 2. RIP 1 is way old. RIP 1 does not exist anymore. Even RIP 2 is old, but it is used very, very in a small networks. In a big enterprise network, for example, let's take like an American Express or a Visa, like that. If you see a big networks, you will never see a routing protocol exists with like RIP. It's way age old, you know, but it still exists because of the CCNA syllabus, because to understand the distance vector protocol, to understand how does the routing works, right? So let's talk about RIP version 1, just for the book, right? No one uses it, but you still have to understand that. So RIP version 1. RIP version 1 is a classful routing protocol. It is a classful. What is classful routing means? I will not set my group identity to my neighbor. I will not advertise my subnet mask to my group. For example, let's say there is a group. There are 3 members in the group. When I send a message, if I say, okay, I am part of this group, for example, let's say this group name is maybe, let's say this is, for example, it's called Team A. And when a Team A person sent a message, he will say that I am also a member of Team A. So that message will go to all the players of Team A. Similarly, the classless routing protocol does not say it is a Team A. So his message will go to all the members in the network. For example, there is a person of Team B. They also get the message because RIP version 1 is a classful routing protocol. It does not share its subnet mask, meaning it does not share its group number or the subnet mask to other members. Whereas the RIP version 2 is classless routing protocol. RIP version 2 is classless routing protocol. Meaning it will send its subnet mask information to others. That way, its message is sent to only its peers. For example, when R1 sends a message, if R2 and this R2, if they are in same of one group, then only this message will go to them saying that, hey, I'm coming from a /24 network, which is a subnet mask. But RIP version 1 does not do that. What does the RIP version 1 does is it will simply do the broadcasting. It does not send the message to members in the group with the subnet mask, but it just broadcasts the message to everyone. Can anyone tell what is a broadcast?
Sending it to all the ports.
Yeah, sending to all the members of the port without worrying about who is destination listening, right? It will send that message to all of them. So RIP version 1 just uses the broadcast, but the RIP version 2 is a classless protocol, meaning it sends its subnet mask information to the specific numbers, to the peers of the specific subnet mask. So the RIP version 2 will send the entire routing table for every 30 seconds. For example, let's say RIP version 1 has a routing table. For example, it has the routing table of 1,000 routes. Like route entry 1, route entry 2, route entry 3, route entry 4. There are 1,000 routes in the routing table. For RIP version 2, will send the entire routing table to the connected routers. Hey, it is my routing table. You can check my writing table with that. So it will send it will share its route database to other peers, which for every 30 seconds. This is okay as long as your network is small. But consider you have like 10,000, 15,000 routes. What does it cause is when I keep on sharing my route database, to my neighbors, it will cause bandwidth consumption because my route table is very big. If I keep on sending the routes between the routes, if I keep on sending the big routes between both the routers, that will cause the issue with the routing table. So it's not a good idea because it will consume a lot of bandwidth, which will cause the network convergence. Have you guys understood the term convergence? Do you know what is a convergence is? No idea about convergence? I think I'm using the term multiple times by now. I thought you guys know about it, right? So convergence means, let's say, there are two. This is source, this is destination. There is only one road. I mean, let's not talk about the networking for a second. Let's talk about regular source. For example, this is maybe like downtown, and this is something like midtown. There is only one road between them, between the downtown and midtown. What happens if there is only one road? The trucks has to go through this link. The cars, the bicycles, everyone has to go through this one road. So what does it cause? It causes traffic. Right? It causes more amount of traffic on a single road. And what it will cause? It will cause the delay of traffic between the vehicles. So this vehicle has to pass, then only the next vehicle can go. So there is delay that is caused between the one vehicle over the other. That is called the convergence, meaning like 2 or 3 packets will converge, will cause the network slowness. Like they move slowly because the path is not sufficient to send more number of packets. And after one packet, the next packet has to go because there is only one path. So similarly, when this router has big routing table, when it's keep on sharing its database, this path will be heavy in the traffic flow, and that will cause the slowness in the network. That is called network convergence is about. Okay, and RIP version 2 also supports authentication, meaning like if I want to form a neighborship, for example, if I want to share my routes to my neighbor, I have to form a neighborship between them. Otherwise, I cannot send the routes, right? So you can also put an authentication piece, meaning you will put a password here. You'll put a password here. And they both have to match on the password for the neighborship to up. For example, when you go to your friend's house, if you want to get on their network, what will you do? You will ask them for the password. They will give you the password, you type it. So they will match your password. Similarly, the routers, if they want to make the neighbors, to form the neighbor, the password should be matching on both sides. So basically, RIP will help you to understand the better path with the less number of hops. And can anyone tell me the administrative distance of RIP? In the last week, we discussed about the administrative distances, the table. Did anyone remember the administrative distance of RIP?
2.
I'm sorry.
120.
Yeah, 120.
120.
Yeah, 120 is the value of RIP. It provides the AD value that is given for 120. So how do you configure the RIP, right? So you will configure the RIP. For example, let's take 2 networks. Let's take two networks, right? let's take router A, router B. Okay, so this is a network of, meaning like this is a network of the 10.10.10.0/24. There might be a couple of servers in this network, a PC and a printer. Let's say printer, and this is router B, and the router B will has contains like server network 10.10.20.0/24, and this network contains, for example, like an MacBook, right? MacBook is there, and this MacBook should be connected to the switch. Switch will be connected to switch, right? Switch will be connected to the router. You know the idea. We discussed about that, right? So let's say this MacBook want to talk to this printer. Now let's talk about this. So there is a switch here, and there is a switch here. Can this printer talk to the MacBook without a router, guys?
No, because they are in different networks.
Yes, because of different networks, they cannot communicate. If they are in the same network, we could have put simply a switch between them, and then they should have able to communicate. But because these are in two different networks, they cannot communicate between them directly. So that's why we need a router. That part is clear. Now, if there are two networks and if there are two routers, can they directly communicate without a protocol? So this is network A with 10.10.10/24. This is network B with 10.10.20/24. So this is connected to router A. For example, let's say this is in one building, and building 1 has router A, and this is in building 2, and building 2 has router B. And we want to make sure the building A printer has to talk to building B or building 1 and building 2. So the building 1 printer has to talk with builder 2 MacBook. Building 2 MacBook, I'm sorry, building 2 MacBook. Can they communicate directly without any protocol, guys?
No, there should be a protocol, right?
Yeah, there have to be some protocol. But let's say like this, if there is a router 1, and let's say there is a switch, and that switch has a printer in one network, and there is a different network, and there is a server or PC MacBook. Let's say this is in network A, and this is network B. Can they communicate directly? Let's say this is 10.10.10.0. Let's write it down. 10.10.10.0/24. And this is 10.10.20.0/24. So, hi Prasad, tell me, how do we make this communication work in the bottom diagram? So the PCA, I mean the switch, the printer has to communicate with the MacBook. They are connected to the switch, and the switch is connected to the router. How can we make this work if there is a single router?
Like, can you repeat the question? I haven't understand that.
Okay, I want you to pay more attention, please. So switch has one port connected to the printer and also a different port connected to the MacBook, and the switch is connected to the router. So can the printer A communicate with MacBook? If yes, how can we make them communicate? What will be the configuration looks like? Let's pass it to Monica. In this configuration, can you tell me how can we make printer A on the left-hand side communicate with MacBook on the right-hand side? They are in two different networks.
By using local area network and cables.
What do you mean by local area network? They are already in the LAN. They are in the same network, but they are in two different sub networks we can call. So let's say this is all one big company. Let's say this is all. Let's say this is. What is doing that? Okay, let's say this is a one big, maybe. I would say maybe a small Chase Bank office. This is one local area network, and there is a printer on left-hand side that wants to make a communication with a MacBook that's on the right-hand side. So this is all one LAN. How can we make sure this will be happening? How can we make sure this can work? What will you do on the switch? What will you do on the router? That is my question is.
By connecting ports and cables.
They're already connected. I'm asking about the configuration. Ports and cables are already connected. On the switch, what will you do? They're in two different networks. What will you do on the switch? Saishri, can you tell?
I think we can use VPN connection.
VPN between printer and
Switch.
printer and
switches.
MacBook.
So from the switch, if we connect to VPN to the network A and B.
Why do we need a VPN in this case? Switch does not know what is a VPN, right? The PC does. I think we are off guard.
Yeah.
Anyone in the class?
Yeah.
VLANs creating.
Exactly. On the switch, you will create VLANs. So you will put this port as, for example, VLAN 10, and this port as VLAN 20. That way you are separating both the networks. Okay, that is done. On this port, what will you do?
Trunk.
You can use
Trunking.
Yep, on this port, you will create a trunk port. And what will you do? You will allow VLAN 10, 20. On the router, what will you do? You will create sub interfaces. Right? We discussed about this, guys. This is called router on a stick model. If you are paying attention to the class, this is called router on a stick model. You will create sub interface on the router, and then you can make sure you can communicate between these two devices. Guys, what are we going to do is, if you are not understanding the concept very well, I think we have to take a step back. We have to understand a little bit more our basics, right? Before we move on to the routing, because if we cannot understand the concept of printer connecting to the MacBook in the same network, in the same LAN, I don't think we are ready to go to the next stage yet, to this class. But I'm going to complete the RIP today. But for tomorrow, I think we have to do a different kind of session. Maybe tomorrow we're going to configure something like a router on a stick model to understand how are we making sure we are able to connect two devices in two different networks using this model. So tomorrow we're going to do a lab, not the theory tomorrow. Let's talk about how do we do this in the real time in a lab. That will give you more understanding that to understand more. So, but this is accomplished to take a step back. This is accomplished using what guys? Router on a stick. So now let's go back to this network, right? So now we know if so this can be a router on a stick. And this can be a router on a stick as well. But the problem is the networks are not connected to a single router. There are two different routers. They are in two different buildings. Then to communicate between two different routers to like two layer 3 devices. What is a layer 3 device, guys?
Router.
Yeah, a router can be a layer 3 device because it works.
Which
it knows
forwards the
about IP
packet
address.
based on the IP address.
Yeah, it can forward the packet based on the IP address, whereas the switch does not understand the IP address. It will forward based on the MAC address. So in this case, the router A to communicate with router B, we need a routing protocol to communicate between two routers. So here we are talking about the protocol called RIP. Is it clear now, guys? Still now, if you don't understand something, please ask. Are we all good? Okay, so RIP, I think I forgot to tell the full name. RIP full form is routing information protocol. So the routing information protocol will exchange the routes between both the routers. And as I mentioned, the router A will share its database to the router B, meaning it will share to the router B saying that, hey, I have a network of 10.10.0/24 as my internal router. I will share that to you. Similarly, the router B will say, hey, I have one of my internal network. So that is 10.10.10.20.0/24. That is my network. So they both exchange their routes between them after forming the neighborship. So to form the neighborship, what is the configuration, guys? The configuration is very simple. On both the routers, what you're going to do is you will configure, like for example, on this router, you're going to do like after entering the router, you will do like configure, and then you will do like router RIP, and then you will do network statement. And network statement is 10.10.10.0/24. Oh, I missed the one here. And so again, router A. What I'm going to do is configure. I'm going to do router RIP and good network statement. 10.10.10.0. That should be fine. Similarly, what we're going to do, guys, on router B, what we're going to do? Configure router network. What will be the network statement here, guys?
.10.10.20.
Yeah, 10.10.20.0/24.
/24.
So the router B is saying that, hey, I have this network as my network. I'm going to send that network to you. Once you configure this configuration part on this router. So once you do the configuration on both sides, they both form the neighborship, and then they will exchange their routes between them. Okay, that is how you will see the information between both the routers once they form the neighborship. So on the RIP, if you want to do like a password, as I mentioned, if you want to secure your neighborship, you want to make sure, you want to know who you are authenticating, you want to make sure that who you want to authenticate by yourself, then you will put a password on router A and router B, and the passwords has to match. If you don't match it, the RIP neighborship will not come up. What is neighborship, guys? Neighborship is nothing but we both are allowed to exchange our routing information between both of us. That is called neighborship. When the router A wants to talk to router B, it will send a message that I want to become your neighbor, and the router B will respond saying that, okay, yeah, you can be my neighbor. What is your password? So they both exchange the passwords and then they become the neighbors. What kind of packets they exchange? What is the multicast group? That is something that is discussed at the CCNP level. But for CCNA level, we are not going into the multicast address of RIP and how do the packets will flow, like the debugging packets. That is not at the associate level. That is also not needed because you're gonna never troubleshoot RIP in your life. We are talking about 15 years back technology now. There is something just to understand the concept only. You will never see a RIP in your life, especially because of people moving to cloud, people want to do the automation, people want to move to SD-WAN, like these are all kind of concepts. Seeing a RIP is like a bad thing, not a good thing. But anyways, so that is about the RIP. RIP is just a routing protocol. It will help us to find the best path using the distance vector protocol. So let's say there are two routers, guys, and to reach the router A, sorry, let's say there are two routers. Let me draw that out. And from router A to router B, it takes 15 hops. And for router A to router B, it takes 20 hops. So Sudhir, can you tell me which path is preferred and why?
I will prefer 15
Wow.
hops by
Why?
using distance vector protocol, like shortest distance.
Yeah.
Like calculate number of hops of the destination.
Yeah. So by calculating the number of hops, whichever has the smallest hop, that path is preferred because RIP is a distance vector. It will calculate the number of hops and select the shortest path for reaching the network. Okay, so that is that. So let's talk about a little bit about the RIP disadvantages. Why RIP is a bad thing, right? So as I already discussed one bad thing. What is that bad thing, guys? RIP will share its database, the full routing database, and that will cause convergence to the network. It makes the network slow, right? We talked about that. Can you think of a disadvantage of the distance vector, guys? Can anyone tell me what is the disadvantage of choosing the less number of hops? Let me ask you a different question. Let's just draw that out, right? So as you know, this will take 1, 2, 3, 4, 5, 6, 7 hops. And 8th hop is the destination. So total took 8 hops. This is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 hops. So obviously this is preferred because of less number of hops. But what if this link go down? If this link went down, this router has to tell that, hey, this link went down, and this router has to tell, hey, there is no reachability. This router has to pass information to this guy, and this router has to pass information to this guy. So there is a delay of communication. When a link goes down, they all has to communicate to the next neighbor until the source knows it. So it causes delay in RIP because the convergence rate is slow. Every router has to tell its neighbor that, okay, the link went down. So it takes time to get past the information. For example, let's say this link went down and this router is too busy and it did not send the information immediately to this router. By the time this will keep on sending the packets to here, but there is no path here to go to the destination. So there is a network outage. Because of this convergence slowness, the networks will be slowly converged. So it takes time for that. So RIP is also a disadvantage on that. And let's say there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So let's say there's one more router, there is one more router, there is one more router, then there is one more router, then there is one more router, and then the actual destination. So in this case, 12, 13, 14, 15, 16, 17, and 18 hops. So from source A to reach destination, there are 18 hops, but RIP only supports up to 15 hops. So if a network is bigger than 15 hops, the RIP cannot support it. The maximum number of hops the RIP can support is 15 hops. If the network is like more than 15 hops, the RIP cannot pass the 16th hop information to all the way to the first router because RIP supports only 15 number of hops. And the last thing is the utilization, guys. As I already mentioned, RIP is not very versatile or very easy to use because it keeps on sharing its database for every 30 seconds. So it will cause bandwidth utilization more, and it will cause network to not to efficiently work. Okay. Any questions still here? Is it all clear? Okay, so let's say there is a RIP protocol, and there is a route learned from the neighbor via RIP, and there is a route learned via static route. Which route is preferred, guys? Mahit, can you tell me when a route is learned from a rip and a route is learned from the static route, which route is preferred?
I think static route is preferred.
Okay, what is the reason?
Because there is the communication between them is easier than the route.
I'm sorry, Mahi, what is that? So the reason is that administrative distance. So the RIP administrative distance is 120, whereas the static route administrative distance is 1. So when the route is learned via static route, that is preferred because the less administrative value wins, right? So in that case, the static route is always preferred than RIP, because RIP is a distance vector protocol with AD value of 120, whereas the static is a manual next hop that is provided by the user, and it has less AD value than RIP. That is why static routing is preferred. Okay. One more question. So let's say this is router 1. This is router 2. There are some PCs here, and there are some maybe servers here. The router 1 is using RIP and RIP here. And the router 2 is learning 10.10.10.0/24 from this guy to the router 2, and router 2 will be sending to router 1 via RIP. Similarly, this is 10.10.0/25. So in this case, R1 to go to 10.10.10.1, which route it takes, guys? So R1 to go to 10.10.10.1, will it choose R2 path or R3 path?
R3 path,
Why?
because of /25.
Why /25?
Like when we do the exponential, it will get like a more hosts.
It is called longest prefix match. Correct?
Okay.
So the answer is
Nine.
right. The answer is right. When you do 2 power 8, right? That will be 256. When you do 2 power 7, that will be 128. So this group is smaller than this group. Because of the longest prefix match, the smallest group is preferred, which has the longest prefix match. Is that what you meant when you said your answer?
Yes.
Okay, yeah. So that is right answer. The longest prefix match wins because of /25 wins. But what if both are /24s? Then what will be happening, guys? What will the R1 consider?
Administrative.
But here both are RIP. This is also RIP and this is also RIP. Both are AD value is 120. So then how R1 will consider which path is better?
R3
Why?
because it has like longest profile. Hosts are
No, both are same. Now I changed the question to /24. Both sides /24. Any ideas? So we checked the longest prefix match. Both are same. We checked the number of hops. Both are same. We checked the AD value. Both are same. Any ideas? Which one will be chosen?
Do we look at the IP address of router 2 and router 3?
No. Some other protocols does it, but not RIP. RIP will do.
Trace route.
Yeah, trace route, even trace route, both number of hops are same, right? Even if you do the trace route, both the hops are same. So for example, for R1 to go to destination, this is first hop and this is second hop, 2 hops. Here also first hop and then the second hop, 2 hops. So the number of hops are matching. So the answer is ECMP. What is ECMP, guys? Equal cost multipath. We discussed about this.
Echo request and that's what.
No. So what it will do is it will send one packet to this guy, one packet to this guy. It will use both the paths. That is called equal cost multipath. Both sides, when the paths are equal, RIP can use, it can go some traffic. You remember round robin? You guys remember the round robin? Round robin is like
Yes.
the cards.
Yes.
Similarly, the RIP router will send one packet here and one packet here. They will share the load on both the links to go to the destination. So if you see the routing table, it will choose 2 paths in the routing table. To reach the destination, there will be 2 paths in the routing table. The path 1 is via R2 and the other path is via R3. So the load is equally shared when the number of hops, AD value, and the prefixes are same. Then, I mean, the prefix length is same. Then it will be equal cost multipath. Both the paths will be load balanced between both the routers. That is called equal cost multipath. Okay, that is about RIP protocol. That is the class for today on the RIP. How does the RIP work? And how does RIP shares information to the neighbor? And what happens when there are multiple hops? How does the RIP select the best path? And what happens when the prefixes are different? How does the RIP select it? And what happens when the paths are same? How does the RIP behave? So we talked about disadvantages of the RIP. We talked about the versions of the RIP and also how it calculates the best path. And we also seen the configuration on how to configure a RIP protocol in the network. So that's it, guys. I don't want to start a new protocol like OSPF or PGP because I don't want to confuse on the same day. But tomorrow we're going to talk about the next protocol, which will be OSPF. And then we'll talk about EIGRP. And last thing about BGP. So every week we'll talk about one, every day we'll talk about one protocol. And that will be agenda for this week. But this is RIP. Any questions on protocol RIP or any general routing table understanding? So who haven't submitted the questions, I think please submit the questions by tomorrow at least. And whoever did already, thank you. I did not review it. I'm still reviewing your first test questions only. But I plan to give more time and I'll complete that by end of next week. I mean, by end of this week, before we go to the test 3. Okay. And I plan to do that. I have to dedicate some time for that. Let me stop the recording and then I'll leave the class for questions.